and today I'm very happy to have Matthew Bonig with me. So Matthew is, well, I think very well known in the CDK community. So we did co-found the cdk.dev website and Slack channel with a few other people last year. And yeah, and today we are going to talk about 3 do's and don'ts in terms of the AWS CDK. So, but before we jump into that, over to you, Matthew. Would like some self-intro, perhaps?
Yeah, thank you, Sebastian. I really appreciate it. As you said, my name is Matthew Bonig. I am a DevOps engineer, former developer, and I work for a company in North Carolina here in the US. And our job is to help our customers adopt AWS technologies, both at a small and medium business level. So my job is to really advise on the best use of AWS and then also hands-on keyboard and implement both that infrastructure and the development pipelines and life cycles and things like that. So today I wanted to kind of hit some of the big 3 do's and don'ts that I have come across over the course of my time working with the CDK over the last 2 years, and just try to help share them and hopefully keep people on good tracks that keep them out of trouble long term.
Awesome. That sounds good. And I've also, well, you're also writing a book about CDK with a few other folks. That's correct.
That is correct. Yep.
Like on like the elevator pitch. What is the big book about?
So back in the spring, Thorsten Huger, I hope I'm pronouncing that name right. I should know it by now. I'm bad at it. Satya Bhatt, Matt Coulter of the CDK Day fame, and I got together, and we had all been approached separately about maybe writing a CDK book, and we all separately said, no, we don't have the time or the skills to get it all done. But then we all came together and said, but together we could probably do it. So we have been all summer writing individual chapters of the book. We are hoping to have that published in time for reInvent. Stay tuned to the CDK book on Twitter, or on listen to me on Twitter at Matt Bonig, and we will let you know as soon as it's available for pre-order. But the goal of the book is to really cover as much as we can about the CDK product, how to leverage it to the best of your abilities. Some of the things that we're going to be talking about today are covered much more in depth in the book, and hopefully everybody gets something out of it. We're going to be covering a lot of things, from testing to construct development to upgrading from 1.0 to 2.0 and all that good stuff along the way.
Awesome. Sounds very cool. So, and you can already, I believe you can already sign up for like a newsletter or something like this, like once it's released, or like once it's done for.
Correct. If you go to the cdkbook.com, there is a form on there to sign up. You'll be notified when pre-orders begin, and the website covers all the details. It even covers, I think, a table of contents for the book, which might need a little revising. We've both added and removed some content that we had originally designed on.
Awesome. Well, really looking forward to the book. Yeah, hope it's going to be published soon.
Hopefully very soon. Oh, and late development on this. We have been playing around with this for the last probably about month and a half. But at this point, we are going to be publishing the book in 4 varieties. So if you go and you purchase the book, then you will actually get 4 PDFs, 4 ebooks when it's all done. You will get one where all of the examples are written in TypeScript, one where all the examples are in Python, Java, and C#. So regardless of the language you use, sorry, Go isn't supported yet. Hopefully we'll get there someday. But regardless of the language, you'll be able to see all the examples in it. We are using the JSII Rosetta module. So the same. So same basic underpinnings of the CDK to support multi-languages. We leverage that same library and that same code to do a conversion of all of our TypeScript examples into the other languages. It's not 100%
awesome.
perfect. We're trying to get it there so that everything reads. It should all compile. It may just not be idiomatic, but it will at least hopefully get you along the way and hopefully make everybody pretty happy. Python's going to be the big one. We got a lot of questions about Python, and that one seems to be a pretty good translation right now.
That's cool. So that's essentially the same tool which is used for the docs, right? So like for the docs translations. And awesome. Cool.
Exactly. Yep.
That's amazing.
Yep. Using the CDK to write a book about the CDK.
That's the way it should be. All right, then let's dive into 3 do's and don'ts with the AWS CDK. And I'm gonna bring the screen up in the stream if you're ready.
Yep.
Yep, cool.
All right. So as I said, this is a culmination of things that I have learned over the course of the last couple of years, creating a lot of CDK code along the way for various clients, for my own personal projects. Of course, when we spun up the cdkbook.com website, that's all handled through CDK code. So along the way, I found 3 good practices that I believe everyone probably should be following when they're writing CDK code, and 3 things that you may be tempted to do, but I would highly recommend you don't. So we'll get started with the first one. It's pretty straightforward, and this is a major topic within the CDK book itself, which is you should be writing unit tests for all your code. And the reason for that is because it really is going to provide a lot of value long-term for the functionality of the system and the functionality of your code and as a whole. So if we take a look at a simple example here, this is a stack that has in it a S3 bucket, a CloudFront distribution, a hosted zone in Route 53, a certificate at a certificates manager, and a CNAME record that we can use. This code isn't 100% actually functional, but I didn't want to boil it or weigh us down with details of all this stuff. In essence, this is a very simple stack with a couple of different constructs in there. So
can you
if I wanted,
font size a bit?
Sure.
Like a bit bigger, yeah. I think that's better.
How's that? Is that better?
Yeah.
Okay. So now this is the code that's been written here is very straightforward. It's very basic. Thanks to type safety and all the goodness of a strongly typed language, I can write this code and it probably is going to be 99% correct right out of the gate. I probably don't have to worry too much about functionality directly related to these resources. So I may not really have to write tests to verify that this is all correct. These things are simple enough and we've all been doing this work enough that, I could probably write this from scratch and be fine. But I'm going to still want to put some unit tests around that. And we'll get into in a minute why those are going to really pay off over time. But I wanted to highlight how simple it can be to write unit tests for CDK code. So I've got this thing already built. Now, if I was a test-driven development practitioner, I may argue that I should have written the tests first and then wrote this code. But let's face it, not everybody is TDD. And while I'm a big proponent of the methodology, I use it a lot for my API development and sometimes for my CDK development. But a lot of times I just throw together this code. But I still want to verify afterwards that it's kind of what I expect it to be. So if I come over here,
so like actual test-driven CDK development, like you mean beyond snapshot testing? Like actually, I have some expectations, like this role should be named like whatever, and or should have these and that permissions, stuff like this, or?
Yes, although I usually reserve it for when I have a little bit more complex logic in there. So for example, let's say I was creating this stack and I wanted to make it so that I could pass in a hosted zone. So I could say if a hosted zone was provided, then I'm just going to use that provided hosted zone. Whereas if it's not, I may want to go ahead and create a hosted zone. This is what we typically call business logic. If I was talking about API development or application development, it's that conditional, the for loops, the switches, those things that depending on input will vary the output. As this stack stands right now, there isn't really any input to it. I don't really pass anything on the props. I don't really use them in any way. But if I was going to start building this type of logic into my constructs, then I'd probably take a TDD approach to it, just because it makes me feel better that from day one, I've got all my code laid out the way that I need it to be.
Okay.
So let's say I've got this and I want to go ahead and retrofit some unit tests over that. I can hop over to my test file. This is going to be bootstrapped for me by either the CDK init process. In this case, I'm using Progen for all of my CDK code now. So I go ahead and just open this guy up, and I'm going to go ahead and start typing out a test. Now, I highly recommend you leverage your IDE as much as you can to be a fast and quick developer. We're going to have a chapter in the book dedicated to how you can leverage either Visual Studio Code or IntelliJ to the best of your abilities to make writing CDK code nice and useful. In this case, I'm going to use something called a live template. In IntelliJ
like snippets,
process,
snippets essentially.
Right. In VS Code, they're called emmet snippets. Here, they're called templates. So I'm just going to come in here and I'm going to say a CDK snapshot test. So it goes ahead and automatically fills out the basic boilerplate for a test for me.
Size again? It's really tiny and blurry.
There we go.
Yeah.
So I get this little template, and part of this live template was to name what it is specifically out of the template that I want to test. In this case, I want to first look at the S3 bucket. So I'll go ahead and put this in. Let me go ahead and fix up my imports while I'm here. Notice here too, I'm using the new assertions library out of the CDK. If you haven't started adopting this yet, I highly, highly recommend you do. It is has some very nice cross-language compatibility. It also makes it very easy to work with CDK-specific code. It's very nice for these unit tests. So there you go. I have my first test written up. I can go ahead and run this test. And now, because this is a snapshot test, the first time it runs, it's always going to pass. I'm always going to get a successful test in this case. So I'm going to go ahead and just take a look at the snapshot real quick that was saved. And I can see I get a basic website bucket definition. There's not a whole lot in here. I didn't create a whole lot of properties, but I can take a quick look at this and go, yeah, that's what I want, or no, that it's not, and go back and change it if need be. But there we go. I've got a test. And that's all I needed to have a nice set unit test on this S3 bucket. And I can go ahead and continue on down the road here and go ahead and create another snapshot test for the CloudFront distribution. And if I go ahead and I run this test now, it'll go ahead and effectively run very similar code. It'll take a snapshot of the current state of it. And again, I can go back and see, yes, this is what I would generally expect out of a distribution. I may need to kind of drill into these a little bit, but I can take a quick look at this and go, yeah, that looks about correct. All right.
So it will prevent change, right? So like once you locked it in, it's like whenever you change something, this would be prevented by this.
Exactly. Now we're going to leverage that a couple of ways moving forward. And let's actually go ahead and talk about that real quick. So let's say we go back here and we talk about the do number 2. What's our number thing that we always want to do? Number 2, we want to refactor our code frequently. We want to make sure that the code that we have is easy to read, easy to understand, and easy to maintain going forward, because CDK code is general purpose language code. You can write it 100 different ways, and if you want to, you should be able to change that in the future without too many problems. Unit testing is what allows us to do this next step very, very easily. So what do I mean exactly by refactoring? Well, if I go back here and I take a look at this stack that I've created, I can see here that what I've got is a bucket and a distribution. Well, a bucket can host a website. In fact, I even missed the property on here, I think, for, I got to add in an index.html to get this to register as a website. But I create this bucket, and by itself, it's not going to be very useful to me. Buckets in AWS can't handle SSL certs, at least not the last time I checked. So you always end up having to put a CloudFront distribution in front of it if you need them secured because it's hosting a SPA application with a login form. So logically, when I look at these two things, they're kind of one thing to me. I can't really break these things up and keep the functionality of the system. These two things together is what gives me that functionality. Now, I could probably argue that all of these things together really make up one unit of functionality, but this sort of definition of what is a unit to you is completely subjective. It's going to vary from project to project. It's going to vary from resource to resource. But just for the sake of the argument, let's say I wanted to consider this one thing, and maybe this sort of thing is something that I want to be able to recreate very easily. Well, I should be able to refactor that. I should be able to rearrange my code without necessarily changing the functionality of it. And one way that I may do that is by introducing a new construct. I may create a new one of my own that I just call a website. And I'll give it a name, I'll give it an ID, and I won't worry about giving it any properties for now. But let me go ahead and actually, I've got a live template now for doing this. So I'll say construct, and we'll call this, I love these things. So I'm going to go ahead and create this website construct. And I'm just going to go ahead and copy and paste, cut and copy these things out of the stack directly, and now make it part of this construct. So now I have this construct that I've created called website, and it is sitting in here just fine with all of its properties. And now it encapsulates these two things together. And this is a very common pattern within the CDK, where we use a construct to encapsulate common functionality, to group them together so that they're easily reusable. Now, if I go ahead and do this, if you've worked with the CDK code before, you know what's probably going to happen next. If I go back and now I rerun these tests that I had before, I'm going to see failures in these tests. And that's because when I moved that bucket resource and that distribution into a new construct, it inherently changed the name or the logical ID in the CloudFormation template. So let's see if we can make this a little bigger. Yeah. So before, what I had in my snapshot here in yellow was a logical ID for the bucket called website bucket and then a hash code. But now, because I've rearranged things, that's actually changed a little bit. Now it is website bucket and a new hash code. Well, if I went and I deployed these changes to an existing stack, CloudFormation is going to see that as a new resource, create the new resource because the logical ID is new as far as it's concerned, and then delete the old resource. And that's not ideal. In the case of a distribution, not horrible. I mean, you're talking about 20 minutes to create a new one, probably a few minutes to tear the old one down. So it's a little bit slow, but distributions are effectively stateless, so not a horrible loss. But the bucket is not. A bucket has state. It has objects that are in it. And if I was to change this website bucket logical ID and try to delete the old one, I'm going to lose all that state if I have that auto delete flag turned on in my bucket. Otherwise, it'll probably just either retain the bucket or whatever. I don't really want to lose that bucket along the way. So in this case, the unit test has protected me from accidentally deleting resources out of a stack and recreating them. And that's really important because not only was this a change that I was expecting because I made the change. If you worked with the CDK as they do their weekly releases and as they go from version 81 to 82 all the way up to, I think, 129 we're at right now, there are subtle changes that get worked into those constructs over time, either because it's an experimental construct that you're using and there are expected changes that come across, or because maybe it was something that they kind of changed behind the scenes. One of the nice things about constructs is they have intelligent defaults. Well, if it's an intelligent default, it's a value that you haven't provided specifically, and it's inherent in the construct itself, and that could technically change over time. There was a situation on our CDK Dev Slack channel where someone came back and they said, I didn't even make a change to my RDS database, but there was one of those smart defaults that changed behind the scenes, and now it wants to replace the database. A unit test will catch that because it'll see a change in the CloudFormation template, and your build, assuming that it's running unit tests, would then fail and stop before you accidentally wiped out a database in an environment. Very, very good thing. So
I'm also aware of like one case where I think it was a Lambda trigger which wasn't triggered anymore, like by default for some reason. I'm not sure if the package was broken or if it was by like was designed that way. And this didn't really got caught like for like a few days or so until someone wondered, well, where are all the Lambda invocations, and which should have happened. And I think in this case could have been caught by this, I guess.
Right. So this is one of the big values behind just slapping these quick snapshot tests over your entire stack, is because it'll help you catch those things that you may not expect to happen, but also help you resolve those issues like this refactoring that you did expect. So how would we fix this in this situation? Well, first thing I'm going to do is, I put in that additional property for the website configuration, just so that we're not muddying the waters here. I'm going to go ahead and get rid of that option real quick. I don't want to make this, go off in too many different directions. But now what I want to do is I want to override what the logical ID is of this bucket, so that it matches up with what was in the snapshot. It matches up with what I've already previously deployed, and therefore I don't get a new resource along the way. Now, this is kind of all a moot point if you've never deployed the stack before. If you're doing your initial development work on this and this stack has never been deployed before, then you can change the logical IDs all you want and it doesn't matter. But this is those situations where, wait, no, I have deployed it. I don't want to wipe out those resources. Let's maintain them. So the CDK makes that really easy. I'm sorry, it sounds like you might have been ready to ask a question.
What would be the case like if you would create like a new bucket, like a new website bucket on root level again? Like, wouldn't you then run into conflicts? Or
you probably wouldn't run into a conflict unless you were specifying the name directly. I tend to never specify my bucket names. I don't want to, because they're globally unique. It means that I'm now having to make.
I don't mean the bucket name. I mean the ID, like the construct ID. So which I'm probably going to override now.
Yes. Yeah. So the CDK does give us the ability to override the logical ID, and instead of letting the CDK deduce some value like website bucket 222 EFFC9, we can specify it explicitly. And the way we do that is we take, in this case, I can use the default child off of the bucket, because a bucket really only has that one child record on it. But I'll use the default child, I'll make it a CFN resource, and then I'll say override the logical ID. And now I can just go ahead and copy this value right over in here. And now if I go back and I rerun this test, it should pass with flying colors.
So the node in this case is the constructs node, or like the construct node coming from the constructs library, right? So like this is like the constructs tree, like which is behind all these CDK constructs.
Yeah, exactly, because we've got our construct, and that is in this case an L2 construct, and it has one or many L1 constructs. Technically, it could also have other things underneath it, but in this case, we've got our L2 bucket and then our L1 CFN bucket. I could have just also done this and cast this to a CFN bucket, and it would work just the same. But I tend to, when overriding the logical ID, just cast it to a CFN resource, which is what all L1 constructs inherit from. So it's a valid cast. So as you can see now, our test passed our S3 bucket. And even though we've refactored this bucket into a whole new construct, since we overrode the logical ID, we can go ahead and this test passes now. And if we want to, we can do the same thing for the distribution. So I'll get a reference to my distribution. I'll say the distro.node.defaultChild as a CFN resource. I'll override its logical ID. And again, I'll just go back to the test here, get what the value was originally.
I'm wondering, is there perhaps like an issue or something like this which allows like a nicer API to access this functionality? You know, like rather than having to deal with internal constructs.
Yes, I'm glad you asked. So this way of doing it, if you notice here, I did rerun the test. It is still erroring out, but it has to do with this target origin ID. We could drill into the details of this, but this is a case where there was an ID to change, but it's not technically a resource within the CloudFormation template. So it's much, much more difficult to overwrite, but it's also something that is entirely within this resource itself. In fact, if we notice here, what's happening is that on this distribution, the default caching behavior is being set and targeting this origin ID down here. Well, that origin is just defined in the same resource just down below. The fact that this ID is changing doesn't actually matter to me because it's not going to cause a recreation of a resource. So this is one where I'd actually be okay with this ID changing, and I wouldn't try to override it. It would be very difficult to do. And I'm going to just sort of leave this as a known failure. I would update my snapshot and move on. But to your point, this is really ugly code. This is not a great way of handling this. I don't want to go into the details of it because I want to stay on our do's and our don'ts. But in the CDK book, there's the chapter on testing, and there is a section of that chapter dedicated to refactoring. And in it, I detail out of the way that you can use an aspect to override these logical IDs. So you would have a stack. You would have all these resources in the stack. And if you needed to override those logical IDs, you would add this aspect to the stack. Now, if you haven't worked with aspects before, an aspect is something that will go and look at every single resource within a construct and allow you to either evaluate it, change it, or report on it. Because what ends up getting generated out of all of this is a tree, then the aspect just goes and starts at the very bottom and goes, okay, here's this L1 resource. Do you want to do anything with it? Here's this L1 resource, and so on, all the way until you've evaluated the entire tree of your CDK stack. And you've either made changes along the way or reported errors or do whatever you want to with it. It's a very open API in terms of how you do it. Well, in the book, I show you how you can write an aspect that you give that aspect, here is the logical ID that's being generated, and here's what I want to change to. So you get a very clean API for doing these overrides, and it's the aspect that's responsible for doing this override call here. And it makes it much, much cleaner, makes it much, much more reusable. This is sort of a down and dirty way of doing it that I just wanted to show in this case.
Yeah. Okay, cool.
All right. Now that's one step of refactoring. This is when you want to refactor your CDK code. However, I want to point out that there's also the refactoring of your tests as well. If we go back to these two tests that I've written so far, I have got some duplicated code between the two of them. In the first test, I create a new app. I create a new stack. I create this assertion object so I can start doing evaluations against that stack and things like that. At this point, I would probably go ahead and refactor this code a little bit so that I'm not duplicating things over and over. Because as it stands right now, if I all of a sudden added a property to this stack, some sort of value that I want to pass into it that was going to change the way the stack was generated, well, now I have to do it in two places. But that's because I only have two tests. Ultimately, I probably want, well, if I go back and I look at my code here, I've got a bucket, a distribution, I've got a hosted zone, or a certificate, and a CNAME. So I've got 5 different constructs I'm creating here. I'll probably have 5 tests. And if I suddenly add a property to my stack, I would have to go and change code in 5 places, and that's not good. So what I would do is I'd go ahead and I would refactor this as well. And I'd introduce a new method in here. I would call this something like create test stack. And now this code down here changes and I got create test stack. Now, if I needed to add a property to my stack, now I'm only having to add that property in one place instead of 5. And it's these types of refactorings that you can do in your code that will make it easier to maintain, easier to read, and easier to live with long term.
Like, out of curiosity, like a template from Stack, could I just pass in some like raw CloudFormation there as well, like a theory? You know, like rather than having like a full CDK, could I just put out like some string there?
So template, yes. When you use this template method, you can hand it just raw string value. You can handle it. You can hand it a JSON object, or you can hand it a stack. The API is still technically in development. I believe it's still marked as experimental. And at the last, I think at least 3 or 4 releases of the CDK, they've been continuing to add functionality to it. So it's something that you'll need to keep up with a little bit, but it's a very useful module and it's worthwhile to do.
Before we move on, there's like a quick question on the book.
Sure.
Is there an in-progress release of the book? We covered this like briefly at the beginning already, but perhaps you want to say like a sentence or two.
I've been teasing a little bit about the progress of it from time to time as I cover, writing a certain section or whatnot, but that's mostly just to gain hype. As it stands right now, I would say we're very close to having the book written up, buttoned up. We have started the editing process to go through and make sure that we're consistent as far as trying to make 4 authors sound similar and make sure that we don't have any grammatical errors or things like that. But we are hoping to have the book released by early December. That's our goal at this point, and there should be an official announcement coming out here very soon.
Cool, thanks.
All right, so got all this. Let's go ahead and step back. So we've talked about unit testing, how unit testing and making sure you have unit tests on all of your code make it that you can do refactoring much easier along the way. And refactoring is good because it allows you to create more maintainable and easier to read code. The third one I suggest is pipelines. If you go and you follow the CDK workshop or you see any of the examples or anything like that, very often deploying out code is a matter of hopping down to a CLI command and typing CDK deploy. And whatever your current AWS credentials are within your environment will be used to take that code, synthesize it, and push it out to an environment. And this is generally okay for when you're doing some initial development. But as soon as you get into deploying to a real environment, something that other people are going to be hitting, something that's going to see real traffic, immediately get into using pipelines. Now, there's a couple of options that you have there at that point. You could use a pipeline that is built yourself using Circle CI or GitLab or GitHub Actions, whatever you want. The CDK does have a second-party module called Pipelines itself. This has been out for, I think, about a year now since its original release. It was originally this CDK pipeline construct that did all of the heavy work. However, they have since deprecated that in favor of code pipeline. Now, this code pipeline construct, it is not to be confused with the AWS service code pipeline. Although it uses it, it doesn't necessarily depend on it. Little bit of a weird naming convention, in my opinion, on this point, because it is very confusing. Am I using code pipeline that's the service, or am I using code pipeline the construct, or am I using code pipeline the construct for the service? Who knows? But this is
it's not when you're saying it's not depending on this, like the code pipeline construct is not depending on code pipeline, does it mean in theory I could swap it out like some custom runner?
Yes, that's the goal. The current iteration of it, I believe, is only leveraging code pipeline, the service, for creating this automation, for getting your source code, building this CloudFormation templates, running the change sets against all of your various environments. However, one of the reasons why they deprecated the original CDK pipeline construct and created this code pipeline construct is because this has a better interface and back end so that in the future, you could swap out the AWS service code pipeline for a Circle CI or a GitHub Actions or a GitLab or potentially any sort of other automation pipeline like Jenkins, while still retaining the same CDK code. It's not quite there yet. It's still in development, but I think that's the end goal of this construct, is to make it so that the actual engine behind it can be swapped out and changed and use whatever you need to. Because while a lot of people do like code pipeline, the service in AWS, I use it for most of my deployments, mostly because its integration with other AWS services is just really convenient. I've also got clients that are standard on Circle CI. And right now, if I want to deploy out my CDK code versus via Circle CI, I'm writing that entire automation myself. And it's fine, but it would be really nice in the future if I can just use this construct and say, oh, I want to use the Circle CI engine, and I'm done. So that's my third. The third do is try to, from the very beginning, from very early on within your development process, to always have pipelines set up for these things, because they will do some very nice things like automatically test your code and run all those unit tests, so that if you possibly had one of those resource swaps, the pipeline will not deploy the code out if your unit tests fail. And that's a very, very good thing. This is a process that we've been doing in application development for years and years and years. It is well proven. If your unit tests don't pass, you don't deploy the code. CDK is no different in that respect. If your unit tests for your CDK don't pass, you shouldn't be deploying changes into an environment. And this code pipeline can make it very easy to enforce those things. I won't go over in this particular case all the setup for it, but really at the end of it, what you end up doing is just creating a code pipeline construct. You give it a couple of parameters into it, and they work out all the complexity behind the scenes to make sure that it deploys the way that it's supposed to. And it's very nice, very useful, and I highly recommend it.
Have you done like really complex pipeline orchestrations with that, or like like multi-account, multi-region? I don't know, things like that.
Yeah, in fact, we have for my company, we are an MSP. We are managing over 50 AWS accounts for our various clients. And in every single one of those accounts, we deploy out the Prowler tool to do a regular investigation of the account security. And all of that's being handled by a CDK pipeline, thanks to Martin Mueller's CDK construct that wraps up Prowler into a very nice, easy to deploy feature. So it took me about a half a day, and I was able to build a CDK application that used his construct. I defined out all of the various accounts that we had within our organization, and then used Code Pipeline to push these things out. And it orchestrates all of the multi-account, multi-region concerns for me. And I generally never have to worry about it. Very useful.
Cool.
All right, so let's move on to the don'ts. We talked about the things that are good. Let's talk about the things that are bad. Number one, don't put everything in one stack. This is very common. So yeah, the reason why you don't want to do this, let's go back to our example here of this stack. So just so things are a little bit easier to kind of see in one screen, I'm going to go ahead and take this stuff that I had refactored before. I'm going to move it back over here into this. A little bit of cleanup. Okay, so let's say I have this stack and I've got everything in this one stack. All right, so now let's say I make a change. Let's say I want to enable bucket logging into this website bucket. So I come up here and I change this property, and I go ahead and I commit my code, my pipeline starts, and it kicks off. When the change set is applied to this stack, I'll probably see the change that I intended to make. But if I haven't deployed this stack in, say, 3 or 4 months, and if I happen to do a version update to the CDK, I may also see a couple other changes come across with it. And some of those changes I may not want to make yet. And there's no way to easily say, well, I only want to make these changes to the stack and not these other changes. I would actually have to go in and synthesize the template and then manually hack away at it to make it exactly what I want it to be. But there's also another reason, is that if I've got, say, a RDS database in an environment and I have the application that sits in front of it, I may be making changes pretty frequently to that application. But I know that that database holds all of my valuable information. It holds all of my stuff. I don't want to make any change to that database unless I'm explicitly making a change to that database.
Yeah.
And if they're in the same stack, I can't really guarantee that very well. I would have to put in a bunch of checks in place on the change set and in my pipeline to say, Well, evaluate the change set before I execute it. And if you see any change to my RDS database, well, I just don't want to apply that. Or, I just fail the change set, I fail the pipeline, whatever it may be. But if you're in a hotfix scenario, if you're in a break glass scenario and you need to make changes quick, you don't want to be worrying about those concerns. So putting everything in one stack means that you're actually adding a lot more complexity than you really need to. And it also violates a central tenet of good application design, at least in my opinion, called single responsibility. A stack is an atomic unit of infrastructure. Everything that's in a stack is considered a single change. Everything that's outside the stack is considered a separate change. And if I'm going to make a change to that stack, then it's very hard to guarantee that I'm making a change to only one little thing in there and not something else. So another way to look at that is that a stack should only really have one reason to change. It should only have one single responsibility and one reason that it changes as time goes on. Now, you could take this to an extreme. Yep.
Yeah. So when you talk about stack, so you're talking about like a full CloudFormation stack, or would you also consider like nested stacks as something like some sort of a unit of encapsulation?
Right, and this is where you get into my biggest beef with a nested stack, is that it's actually very hard to determine those things with a nested stack. If I have a stack and it's got 3 nested stacks underneath of it, and I want to go and apply a change set to that parent stack, it's very difficult for me to know if I'm going to make any changes to those nested stacks, especially if they're complex. If they're very, very simple, no problem. I could probably look at change sets and determine it kind of easily, but nested stacks, because they inherently always change as far as CloudFormation is concerned, it's very, very difficult to sit there and really know, okay, what's actually changing in my system? So the UIs and APIs don't make that apparent terribly obvious. So now you got to go do this investigation, or you got to create the tooling yourself to do it. And it's not a great experience. So I actually avoid nested stacks as much as I possibly can. I don't create them unless one of the constructs that I'm using creates it for me.
Right. Okay.
So
you would say it's like also like a don't use nested stacks if it's like avoidable in any way.
I don't, yes. And I'm sure that there are probably some good reasons out there. However, I've never personally found them. Yeah, I avoid nested stacks at all chances. I think there are better mechanisms in the system. So, when you're designing out your stacks, you kind of look at it and go, okay, also what's the speed of change? What's the velocity of change? If I have a typical 3-tier application of website, API, and database, well, the website's probably changing really, really frequently because, well, CSS changes or moving a form around or whatever. APIs are probably going to change a little bit less frequently, although still pretty rapidly. But your database stack is probably really, really rarely changing. So a typical pattern for me is I create 3 separate stacks for those. I create a stack for the UI side, I create a stack for the API side, and I create a stack for the database side. And that way I know that if I ever need to sit there and do some ad hoc quick change or whatever, because there's a production issue, something has gone down, well, I know I can target just the API stack, or I can target just the website stack, and I know that there's absolutely no risk whatsoever to my database stack while I do this. Now, you could take this argument to extremes and say that, well, we've got one construct for every stack, but I think that's too extreme. And so there's a happy medium that you need to find yourself. But logically, these groupings in your stacks usually fall into natural boundaries within your application, natural boundaries across your teams.
What do you think about using stacks for things like production, staging, like when you have this 3-tier web application and you have like 3 stacks in your application, and someone wants to have like staging and production, how would you do that in this case?
So in those situations, I create a stack that is environment agnostic, that is stage agnostic. It doesn't really care that the stack is not written to be aware that it's for the development environment or the production environment. Those are all properties that are handed to the stack, if it matters. Things like base URLs, configuration values, those sorts of things. And then within my pipeline, each of those environments are grouped as a stage. So I'd have my development stage that has an instance of my database API and website stack with the appropriate values handed to them. And then I got my staging, and then I got my production stage.
Yeah. Okay, that makes sense. Yeah.
All right. So don't put everything in one stack. Split these things up. You'll have to start handing some values around, and you may start running into a little bit uncomfortable situations like deadly embraces and things. If you haven't heard of the deadly embrace, then you probably haven't been using multi-stacks. Adam Ruka's got a great article on it, blog article, go search for it, talking about the deadly embrace and how you can fix it. Basically, the idea is if I've got stack A and some value from stack A, like a bucket ARN, is being used in stack B, well, stack A exports that as a output value from stack A, and stack B intrinsically imports that. Well, if you suddenly then decide, well, I don't need that bucket anymore, and you delete the usage out of both of those stacks, you run into this awkward situation where you can't deploy stack A with the removal because stack B is still technically using that import, and you can't really deploy stack B yet because it has a dependency on stack A. There are ways around this. It's pretty well documented at this point. That's really the only issue that I've ever seen, though, from using too many stacks per se.
Yeah.
So step number 2, don't ever hard code values in stacks or constructs in general. So going back over here to code, I've got a domain name right here that's hard coded in. I just said matthewbonick.com. Don't do this. You don't want to ever do this because it inherently makes this stack not reusable. So how do you fix that? Well, we just make it a property on the stack. So I would sit here and create some sort of new variable on this.
Like a staging domain or like a production domain. That's what we are talking about right before.
Exactly. So to do that, I just come up here and I start creating I have to create a new interface for all of this because I didn't do that from the get-go. And I may sit here and say read-only string. Now, so now this stack has does not know about matthewbonick.com. It's going to be told to use matthewbonick.com, which makes the stack reusable. So as I go to my dev environment, I can use dev-matthewbonick.com. When I go to staging, I can use staging-matthewbonick.com and give that its value. And then when I get to prod, I just give it matthewbonick.com. I see a lot of people hard coding these values into various stacks and things along the way. Even if all you do is pull it out into this stack over here, and let's say I go ahead and say domain is, and I'll make this bigger in just a second. So even if this is all I do is rearrange my code slightly so the hard-coded value sits here at the application layer of my code, where I'm creating my app and where I'm instantiating my stack, this is still inherently more reusable code and will still benefit me long-term. Plus, it also makes it really easy for me as a reviewer, or when I come back to this for the first time after 6 months, to go, where are all my configuration values at? Well, it's easy. I know that if I go to my app right here, if I go to one place, I'll see all of my values. And yes, they may get used in different places at different constructs scattered throughout my code, but I know that all of my configuration is defined in one place. So it's very easy to see. It's very easy to review along the way. All right, so that's number 2. Do not hard code values into your stacks. And finally, this one's my favorite one. Do not make external API calls during a synthesizing routine. So let's go back. We've got this situation here where I've got my stack for the dev environment. And let's say we extend this example out a little bit. And I also create stacks for, say, the staging environment. Stage, and let's say go ahead and do this for prod as well. And notice now, I can very easily just copy and paste some code to be able to use these things over and over again. And technically, this environment's now probably wrong for my stage and my prod, but let's ignore that for now. Okay. So This is a very trivialized example. The fact is, with all of the CDK code that I've written, by the time I really flesh out a fully usable system, I probably have 5 or 6 stacks. Each of those stacks probably take a number of properties on them, maybe 7 or 8 different things along the way. I was mentioning before about how we deploy Prowler out to all of our accounts within our organization, 50 plus accounts. Well, I didn't want to sit there and have to maintain some array in here of accounts where I'm saying, oh, it's, 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 5, 6, 7, and so on and so forth. That's a big pain in the butt. Plus, we were onboarding new customers, pretty frequently. And we didn't want to sit there and have to worry about typing in or keying in a value wrong. So naturally, and this comes up a lot of times, is, well, why don't I just go and make an API call to get this information? It's readily available within the AWS API. I could get a listing of all of my accounts, and then I eliminate a big source of potential typos and bugs and things like that. And while I have done that before, one of the things that I learned a while back is don't ever make that API call within your CDK application. So what do I mean by that?
You mean by application like the app TS file, which we have here, or like how it's called, like in this particular file in general? Or are you, since like in construct itself, it's pretty hard to do async request anyway?
Exactly. So first off, you can't really do an asynchronous call within a construct. You can fake it, but you will eventually shoot yourself in the foot by doing that. Now, what I could do here within this code is make an asynchronous call and then say, don't construct my stacks until that asynchronous call is done, and don't synthesize them until they're done. So it would technically work. But the problem with that is that if I make the API call every time I synthesize the stack, I have now made that stack non-deterministic. And determinism in your stack, in your infrastructure as code, is very important. It's crucial, really. And if you're not familiar with the term, for anyone listening, determinism means that if I take a function or if I take code and I give it the same input, it should always have the exact same output every single time I run it. It doesn't matter if I run it once today. Well, as soon as you make an API call to get data from an external system, that's inherently part of your input, but it's input that you don't really control. It's input that could change on you. Maybe the API service is down and you get a null result back. Maybe it's up and working just fine, but there's a bug in it and it gives you back wrong code. Maybe changes have happened on the other side of that API that you're not aware of, and it's giving you back different data than you were expecting.
So you can run into a situation where you do like a pull request review, everything looks good, you merge it, the pipeline starts to run, and all of a sudden it blows up for some reason, or even worse, it deploys some weird stuff.
Exactly. You would have an unexpected result because the nature of an API call. So what I recommend you do in this case, because the functionality is actually incredibly valuable. And like I said, this is effectively the same thing that I do to manage this Prowler deployment. I make an API call that'll return back from the organization's API all 50 plus accounts we have in our organization. And then I feed that into a for loop in my stage that just goes and creates 50 plus deployments out to all the various environments. But that API call is hidden behind a second script. So what I did was I would go into, in this case, my package file, and I would add in a new script here that says refresh OUs. And that is a completely one-off node script that I wrote that makes the API call, gets all of the data off that API, and then just serializes it down into a JSON file. And then when I go and execute the synthesize routine, when I go here, rather than making an API call to get all my counts, I just read that static file now, and I feed that to my constructs. Now, it may seem like I'm splitting hairs here, but there is a very specific difference between this, in that Because that data then is static within your repository, it's something that you will see during your code reviews, and it is something that is still deterministic. It is still considered input, but it's input that you now control. It doesn't change until you decide to rerun that script and pull down new data. And if it's wrong, you always have that opportunity to see that before any changes get automatically deployed out. So it's much, much safer in the long run to do. So
it's like
this is what
somewhat like a similar idea to using context in like the CDK JSON, like context.
Exactly. It's just like using context. I would love to actually just say go use context to do this. The problem with why I don't usually do that is because context itself is naturally a very flat structure. If I go and I take a look at like the CDK, I don't even have one in here. Typically with the CDK in your context file here in the cdk.context.json, which I don't have at this point, everything is just simply a string to string mapping. You've got a string ID field or key field, and then you've got the string value that goes along with it. And maybe that string value has its own encoding along the way. If you ever do a VPC from lookup, you'll see this. But that's not a very useful structure in a lot of cases. And I like dealing with more robust, less anemic data structures. So it's very easy to make an API call, take that API call, dump it to a JSON file in Node, and then reload that. And I still get my complex structure that's easier to navigate and easier to understand and things like that. But yeah, effectively, it's the same thing as using context then at that point. So that's it. So the rule here is not necessarily don't make API calls, just don't make API calls during your synthesizing routine within your CDK app. Make sure that you always do it outside of your CDK app code. Drop it to a JSON file or some whatever local file that you want to deal with, and then just read that file during your synthesize routine so that you create just enough of a breakpoint between the two that you keep CDK code deterministic. And you will definitely avoid shooting yourself in the foot a lot by doing so.
Yeah, that makes a lot of sense. But I remember that I ran into the issue of not being able to use async requests like early on in CDK when I was starting to use it, and I naturally was expecting, of course I can do this, and awesome, now finally, I can do all the async requests I want to do. But yeah, I think like once I understood the concept behind it and why it makes sense to not do it, yeah, it's quite good that there are like guardrails in place which are preventing you from actually shooting yourself in the foot. Yeah.
Right. And, if you do want to fake it, it's actually not that hard. I mean, all you got to do is, if you've been writing JavaScript for a long time, you're probably familiar with an IIFE, immediately invocable function expression. And that's all you do in this situation is you make this immediately invocable, and then you can sit there and say some results equals away to some API call.
Yeah, of course, but like this only works on top level, like as part of the synthesizing in the construct itself. I don't believe there's a way to do this outside from spawning a new process.
Correct. I have technically made it work before, but you are violating a core tenet of good OOP. Technically, you can do this within, say, the constructor. You could sit there and drop an IIFE in here to make an asynchronous call. But technically, what happens then is the constructor is done executing, but its state has not finalized. And there's no way to guarantee that that state has finalized by the time you try to run the synth on it. So what you could end up with is a synthesize routine that's working on a not completely finalized stack, and therefore it ends up incorrect and not what you were expecting. So generally in practice, it works, but it's something that I tried doing very early on. I actually wrote a blog post about how, hey, look at what you can go do. And then like 2 weeks later, wrote another one saying, please don't ever do this.
Yeah.
So that's it. 3 do's and don'ts. If you have any comments about it, if you think that I'm completely off base with any of this, please let me know. I am always happy to hear about what you think about my opinions. You can always reach me over at the cdk.dev Slack channel. I try to be fairly active over there. Or if you follow me on Twitter, you can reach out to me that way as well. And I'd be glad to always have a debate over any of these things.
Awesome. That was pretty interesting. Perhaps one last question from my end. What do you think about integration testing? So I'm not sure if you have seen the RFC of the AWS CDK in terms of integration testing. And since we are touching on unit testing, and it's not there yet in the AWS CDK anyway, but perhaps what are your thoughts there?
Yeah. So the testing chapter of the CDK book covers 3 basic types of testing that you can do with your CDK code. Unit testing, both in the form of snapshot testing like we covered today, as well as a little bit more in depth if you want to go and actually start to investigate specific properties. But honestly, snapshot testing is just easier. Go with that. Option number 2 is what I call deployment testing, where you take and deploy out to a sandbox environment your CDK synthesized CloudFormation template, because that will expose a number of bugs and errors in your CloudFormation template that unit testing isn't going to be good at checking. For example, if you have to pass over things like role arns or policy names or things like that, snapshot testing isn't going to tell you that you have a typo in it, because you're not going to really notice that. This is the classic problem with doing PRs, is that it's really bad at noticing typos in long strings of text. So deployment testing can verify that, because CloudFormation won't let you deploy a Lambda function using a role that doesn't actually exist. So that's a good sort of second stage. So you sort of start with unit testing as your base level. The first thing you try to incorporate is testing into your CDK code, and then you may sort of extend to or promote yourself to doing deployment testing. So during your pipeline, you may deploy out to a sandbox environment and say, well, if the stack deployed without errors, awesome, that's a good sign, and we move on to actually deploying the real thing out. And then the third one is integration testing, where we actually deploy the environment out and we try to make sure that everything is wired together correctly. This is a very tough subject for me, though. When it came to writing this part of the book, it was a big challenge to figure out, okay, I don't want to cross into the line of application end-to-end testing, because this isn't about verifying your API code. The book is not supposed to help you verify your API code or write your API code better. How do I verify that I, as a CDK developer, wrote everything that I was supposed to write correctly? How do I make sure that not only is the Lambda function deployed correctly, but it has the permissions needed to read and write to a DynamoDB table? So there's some coverage in the book about this, because we're talking about hundreds of different scenarios that you could run into when trying to actually verify that, say, 2 different AWS resources are wired together correctly. It's a very, very open-ended question. It's very hard to give you a good, honest, solidified answer. But the general approach that's taken in the book is that you use a custom resource within your stack to represent your tests that you run against an environment. So I have my stack, like we were talking about before, my website, my distribution, all that good stuff. And then I add another construct at the bottom of it that tests whether or not I can actually hit the website and get back an index.html page without an error. That custom resource then goes and deploys out, and the Lambda function behind it will go and execute whatever that test is against the environment that needs to be run, and then report back either a success or failure as the status of the custom resource. So if your test failed, if you got a 500 error on your website, well, then the custom resource is considered a failed deployment. Then CloudFormation does what CloudFormation does best, and it rolls back all those stack changes, and you are left with a good, clean environment. If things work, then the custom resource is considered created properly, and the stack continues. Everything is up and running just fine. Now, the nice thing about this is that once you sort of abstracted the logic of how to run a test behind the custom resource, you can make it do whatever you want to. In the first example in the book, I talk about how to just test to make sure a basic website is up and running. Second test is how do we check an API running correctly? And it's not terribly more difficult. We just make a sort of a curl command to the API. And if we get a response back, then things are good. The third one, though, is where I think things get really interesting, because it talks about how you would go about testing a pub sub type architecture or an asynchronous architecture, something where you can't just execute a Lambda and that Lambda function can run the entire test, be done, and report a status. But this is something that may require a message to be published to an SNS topic, picked up by an SQSQ, delivered to a Lambda function, and that Lambda function then has to say, yes, I got the message or not, and then report that status back. And to do that, there's a lot of coordination that goes along with it. And because I wanted a good excuse to dig into step functions a little bit more, that's how I showed an implementation for that third use case, is that you have you got your custom resource, it goes and starts a step function execution. The step function does all the testing that it needs to do to verify whatever system that it's meaning to verify. And thanks to step functions incredibly robust feature set now, thanks to its most recent change with the 200 plus services, there's almost nothing you can't do with step functions at this point. So no matter how complex your system is, no matter how difficult it is, you can probably test it with a step function. So then the job of the step function is to simply execute those tests that you've defined and then report back to CloudFormation whether or not they passed or not through the custom resource status. And again, if one of your tests failed, the custom resource goes into a failed state and all of your changes get rolled back, and you are, in theory, left with a good stack, a good healthy stack.
We had like in the first episode here of Cloud Development, I had Matt Morgan, was it? Here on the stream, and we were also talking about like a similar concept, and it was also using custom constructs to do exactly the same thing. I believe it was like a custom construct provider. Is that a thing which is using step functions behind the scenes
right,
in order to achieve pretty much the same what you were just describing? But yeah, like for these kind of complex orchestration workflows, the step functions really seem to be the tool of choice for these kind of scenarios.
Yeah. And with the changes they made recently, with the support for all of those various API calls now supported as first class features within step function, it's going to just take off in terms of a usable service, I think. It was sort of interesting. We started tackling this chapter, and I got done writing the unit test section of it, and I thought, well, we can go further. And I started doing the deployment testing, which I actually called integration testing in an earlier draft of the chapter. And that came from the CDK development pipeline, where you often will, if you're working on the CDK directly, also be expected to submit an integration test. And the simple thing there is, just render a stack out, and if it deploys, then we consider everything good. Yeah. And then I'm thinking, no, we can still go a step further. How do I verify that my Lambda function has the right permissions to read and write from a DynamoDB table? And as I was boiling around this problem with custom resources and, okay, maybe we can use this, and I started doing some testing here and there, it was like 3 or 4 blog posts within a week of each other all came out, and everybody talking about, like Chase Douglas was talking about it from Stackery, about how to do integration testing using some sort of custom resource within your CD code, and Matt Morgan's post, and I saw your video with him on here about it and things, and it was like something was in the water, and we all had the same realization at the same time of, let's use a custom resource to do this, because now we get that automatic rollback functionality within CloudFormation to really ensure that what's existing in environment is correct. And yeah, technically it might be incorrect for a few minutes while the test is running and waiting for it to fail, but that's still a lot better than it going out and it being wrong for 30 or 40 minutes before someone notices. So it's not a necessarily perfect solution, but through other means like blue-green architectures and stuff, you can always get much better, and you can get to zero downtime. But yeah, I'm pretty happy with how that came out. It is very much just here are some ideas, here are some concepts. I'm not trying to say best practices. I'm not trying to say this is the de facto way of doing it. These are just some possible ways that you can get that integration testing done. And hopefully it'll get everybody sort of juices flowing about how can I really test my stuff better so that as a CDK developer, when my code goes out, I know that it's correct at 100%.
Yeah. Yeah, so there's lots of testing in the book, and you should absolutely check it out and sign up for the newsletter and get notified once it's ready. Yeah, Matthew,
Yep.
Thank you very much for being here.
Thank you for having me.
We appreciate it, and
Yep.
yeah, I'm gonna compile some show notes, link a few things which we mentioned across the stream, and yeah, just put it in the description, perhaps like put up some blog posts on, I don't know, this dev.to or like this thing, but I'll leave everything in the description.
Cool.
And yeah, and with that, thank you very much.
Thank you, everybody. Appreciate you.